All right, we're on section 9.4. I can find the perimeter, so let's write the word perimeter. Perimeter is how we'd say that phonetically, perimeter. We're talking about polygons, so what is a polygon? Well, you may remember that a polygon is a closed 2D shape made with straight sides. So it's got lines for sides. So a rectangle is a polygon. We could make any sort of funky shape we want as long as it's made up of straight sides and it's closed off. That's a polygon. And what is a perimeter? Well, a perimeter is the distance around the outside. So it's the distance around the outside. So it's kind of like if you were to fence it off or run a string all the way along the outside. That's what it would be. And then the distance formula, again, we got to have that memorized. So I'm going to write down a d equals a big square root, and then x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all of that underneath the square root. Remember, we got to do the subtraction, square that. Do the subtraction, square that, then add them together, then we can take the square root. And it says, what's the formula for the area of a triangle? Well, formula for the area of a triangle is going to be 1/2 the base times the height, or you can do base times height and divide by 2. I like to think of it as 1/2 times. And then a trapezoid, remember a trapezoid is kind of that wedge shape. Sometimes they come like this, but it's got two parallel sides. It can also look like this. Okay, and these are the two parallel sides, so that's base 1 and that's base 2, and that should be a good reminder. The formula for that is area equals 1/2 of B1 plus B2 times h, and height is the distance from the top to the bottom, or between the two parallel sides. So this right here, that would be the height on that one. Okay, now in the real world, finding perimeters and distances and areas, those can be really useful. So we're going to look at an example right here. It says a rancher in Australia had a plot of land he needs to fence. So he went to his county land office and they gave him a diagram of his property. Each one of these blocks represents 1 kilometer. And it says how much fence will he need. So he's a rancher, he's got to fence things in. And it says distances that are horizontal or vertical can just be counted on the graph. So what we want to do is we want to figure out how much fencing is this going to take. Well, these two right over here, these are pretty easy because it says we can just count. So this is 1, 2, 3, 4, 5, 6. So this would be 6 kilometers right here. And then over here, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 8 kilometers right there. So we've got the two of those. We know how much fencing it would take there, but now we need to figure out how far it is from here to here. So this point is -1, 2, and this point is, let's see, that's 5, 5. So 5, 5. So let's figure out, we'll call this distance 1. So distance 1 or fence 1 would be big square root. We're going to use the distance formula. So it's x2 minus x1. So that's going to be 5 minus a -1. So we're going to take that and we're going to square that. And then plus, this is going to be y2 minus y1. So this is going to be 5 minus 2. And we're going to square that. So we end up with, let's see, this is a plus. So that's going to be 6 squared. And then this is going to be 3 squared. So 36 plus 9. So this is going to be the square root of 45. Okay. Now I'm going to leave that for the time being and let's find the other one. So let's label this as D2. So D2, we need these 2 points right here. So this is -1, -4. And this one is at 5, looks like -3. So to find that distance, we're going to do a big square root, and it's going to be x2 minus x1. So again, it's 5 minus a -1, quantity squared. And then y2, so this is -3 minus a -4. Okay, so that one gets a little bit interesting here. We get a plus on this one, so this again is 6 squared. This one is -3 minus a -4, so that's going to be +4. -3 plus 4 is a 1, so that's 1 squared. So we get 36 here, and we get 1 here. So this is the square root of 37. Now, it might be interesting to think, well, gosh, can we simplify either one of these? Well, this one is 37, it's prime. We can't simplify that, so we're kind of stuck with this one right here. This one is a 9 times a 5, which is a 3 times a 3, so we could change this into 3 radical 5, but it's really not going to make any difference whether you use the simplified one or the other one, because this is a story problem. We probably ought to write down the answer in something that makes sense. So we've got 6 kilometers of fencing along here, 8 kilometers of fencing along here, and then for this one, for D1, we've got the square root of 45, and for D2, we've got the square root of 37. So let's go ahead and write that down. We're going to have 6 plus 8 plus the square root of 37 plus the square root of 45. And let's just figure out what those are. Now, I could figure out each one of these separately, but let's just type this into the calculator and have it figure out what this is all together. So I'm going to put the calculator about right here, and then we're just going to type this in. We're going to do 6 plus 8 plus, and then rather than having some rounding error or anything, let's just type in the square root of 37, hop out on the outside, and then plus the square root of 45. So this is going to calculate everything for me. So I'm just going to make sure I've got the one fence, the second fence, the third fence, the fourth fence. We're going to add all those together, and we get 26.79. So this is going to be approximately 26.79. And remember, this is just a fence, so this would be in just plain old kilometers. So that's not too bad. Let's go ahead and take a look at part 2 of this one. This is the same rancher with the same property, but now he's got a different problem. It says once he has the fence up, the rancher wants to put cows on that property. And in order to know how many cows he can put in there, he needs to know what the area is of this field, this enclosed area that he's got. So it says, what is the area in square kilometers? Well, if we take a look at this shape right here, this is a trapezoid. So we've got, we'll call this base 1, and we've got this is base 2. So this, remember, was 6, and this was 8. But then here's the question. We need to know what the height is, and the height is always the direct line distance, or in other words, the perpendicular distance from one of the bases to the other bases. So we need to know what this is right here. So I'm going to label that as the height. Well, luckily, this is perfectly horizontal, so we can just count. So this would be 1, 2, 3, 4, 5, 6. Okay, so that right there is 6. So the formula for the area is 1/2 of B1 plus B2, so that's going to be 6 plus 8. And then times whatever the height is 6. Now, before you reach for a calculator, let's think about this. I could cancel the 2 with the 6, and that becomes a 3. So this becomes 6 plus 8 is 14 times 3. So we end up with, let's see, 14 times 3. That is 42. So 42 what? 42 square kilometers, or we can say kilometers squared. All right, now we've done all the notes here, so we've actually applied the distance formula and some area formulas and stuff like that. Good thing to recall. Go ahead and fill out the self-assessment here, and then let's take a look at problem 4 from the practice assignment. Okay, I've got the practice assignment up here for 9.4, perimeter and area of polygons. You'll notice that the instructions say find the perimeter and the area, so make sure you do both here. And so for the first couple, they've actually got a diagram of the figure on there. There's number 4. We'll come back to that in just a second. On 4, 5, and 6, they actually just give you some points, so you'll need to plot those and then figure out the best way to do that. Number 7 is kind of another problem for that rancher with a different plot of land. And then we've got a review problem, a mixed review problem here toward the end. But let's come back up here and let's take a look at example number 4. So on this one, I'm going to slide over here and let's take a look. We're going to need to graph this. So let's go ahead and graph the point A, so negative 4, 5. So negative 4, 5, so we're right there. 1, 5, 1, 5 is right there. Negative 4, negative 5, negative 4, negative 5 down here, and then 1, negative 5. Okay, so it turns out on that one, really nice, easy shape. All we have to do is go through and figure out what is the fencing, what is the perimeter that it would take to kind of enclose that, and then what's the area. And you'll notice that this is a rectangle, so we've got a right angle right there. So that one's not going to be bad at all. Let's take a look at number 5. Number 5 is slightly different. On this one, we've only got 3, so that seems like that might be a little bit easier. So let's label H. So this is negative 3, negative 1, so back 3 and down 1. And then we've got 2, 6, 2, negative 6, so 2, negative 6 would be down here. And then we've got 2, 6, so 2, 6 would be up here. 2, 6 would be right up here. So what we would want to do is we would want to find the perimeter. So you've actually got to find 2 diagonal lengths. We're going to need to use the distance formula to find those. So this is H, and this is I, and this is J right here. You'd need to use the distance formula to find each one of those, and then you can just count this one right here. Perimeter is not too bad on that one, but stop and think. This is a triangle, so how would you find the area? You'd have to find the height of this, and a base, you wouldn't want to just assume that that's a right angle right there, because it kind of doesn't look like it. We've talked about parallel and perpendicular, so those are not perpendicular. So what we've got to do is we've got to find this straight line distance from here straight over to there. So that right there is going to be your height, and you can just count that off. Okay, that's enough to get you going on the assignment. Good luck with that, and ask questions if you've got them. Thanks.